So we have two questions which are differentiate using first principle. So I have this question which is very simple and this question also very simple. So using first principle, so I'll start with the first question using first principle. So what I will do, I'll erase like this, then I'll say using first principle, I'll say dy over dx, then I'll say equals, I'll say limit when h is approaching 0, f of x plus h minus f of x over h. So since it starts with y, I'll say f of x is equals to y. Then I'll start the differentiation. So I'll say dy over dx equals limit when h is approaching 0. I'll say since this x plus h, the x is standing for x plus h, so what will happen is I will have x plus h, I'll just square it. This f won't appear, only this part, and then I'll square it, and then I'll say minus f of x is equals to y, and our y is equals to x squared. So here I'll say x squared, then everything over h like this. Then I'll wrap the top part to balance everything now. So you pause the video, you write. So what will happen there is I will have the dy over dx when limit, there is always a limit, h approaches 0. When you expand this the meaning of x plus h, again x plus h, so x times x, that is x squared, then x times h, that is plus x, h times x, that is hx plus h squared. These are like terms, they will add. So you're having x squared plus 2xh plus h squared there. So this part will be written up. So make sure you're pausing the video to see what I've written. So there we're having x plus, so x squared, then plus 2xh, then plus h squared, and then minus x over h. Then from there, x squared as positive, this one as negative, so these they will cancel. When they cancel, we are saying our dy over dx limit when h is approaching 0, we have 2xh plus h squared over h. Then we'll factorize the h. This implies limit when h is approaching 0. We'll factorize the h out first. So say h out, so that we remain with 2x plus 1h over h. So meaning this h and this one they will cancel, so that we say dy over dx. Now we are saying h should approach 0. So we say we have 2x pali h is like 0, which is just dy over dx is equals to 2x. You can test this using the formula method. You just say if This is our final answer. Now, using the formula method, it is very simple to test. What you will do is just this. Our function had our function was y is equals to what? X squared. During differentiation, if you say dy over dx, in this matter, these two multiply to x. So you have 2x, then 2 minus 1, meaning your answer should be what? 2x the power 1, which is this is equals to this. So that is how we solve using first principle.